Hi everyone, I'm going to go over this new lesson on solving Trig equations. This would be your first assignment to look through your textbook and complete these questions here. I'm going to go over a few examples and feel free to pause or look back on it however many times you need to see the examples, but I want to look over questions from example A. So we were looking over what it is when we're seeing inverse trig values, and notice that sometimes with solving a trig equation it means finding the inverse of that. So if you have this equation, cosine of x equals square root of 2 over 2, you want to find the general solutions. It says general because if you substitute this value in for x, maybe if you substitute in, if you're trying to put in for the next value, if you go around by 2 pi, then you'll probably end up with the same solution again. So this is why this is saying that first of all, with cosine of x equals square root of 2 over 2, pi over 4 and 7 pi over 4 would work for that, since it both has the x coordinate for square root of 2 over 2, and cosine is your x value, is your x coordinate. But also keep in mind that you could go around again and you can get its coterminal angles, and that would still give it a solution of square root of 2 over 2. So a way of doing that is by adding integral multiples of 2 pi to find those general solutions. So going by 2 pi and adding in 2 pi times k, where k is any integer, you would add that in to the pi over 4. And same thing with this one, x equals 7 pi over 4 plus 2 pi k, and then where k is any integer. So that's just telling you a multiple of 2 pi. So for example, for sine of x equals negative 1/2, if you go back to your unit circle, where it was sine is where you have your y coordinates, so you want to find where is negative 1/2 as a y coordinate, and that is 11 pi over 6 here. So you could write out for 11 pi over 6 plus 2 pi k. Another one where it's showing that it has a negative 1/2 for sine in the y coordinate is at 7 pi over 6. So you would write out 7 pi over 6 plus 2 pi k. So I'll write that down. X equals 7 pi over 6 plus 2 pi k, and then 11 pi over 6. Oh, x equals 11 pi over 6 plus 2 pi k. For tangent of x, if you go back to your unit circle, you'll find that at square root of 3, it's like you're taking the inverse tangent of that value, and that's at pi over 3. Now, for this general solution, since tangent has a period of pi, you're going to put pi times k. So if you have any multiple of pi, then it's going to it'll get that same solution. Okay, I'm going to go head forward over here. These kinds of equations, you'll find more complex equations like this. And a way of thinking of it is if you look at it as an algebraic equation. So I'm going to show this one on part A here with 8 cosine x plus square root of 3 equals 5 square root of 3. First thing, I want to actually look at it more like this. What if I was just solving 8x plus square root of 3 equals 5 square root of 3? Actually, what we've done in class before is just think of it as a box, right? We want to solve for box. So what do I normally do if I have an equation like this and I'm trying to solve for box? I need to isolate that box. So the first thing I would need to do is, of these, what's on the left side over here, the first thing I would get rid of is the negative is the square root of 3. So I'm going to subtract square root of 3 on both sides. Now when we're subtracting radical expressions, this is like saying it's 5 of these square roots, and I'm taking away 1 of those square roots. So this is going to be 4 square root of 3. I'm left here with 8 box, and to get rid of, to get box by itself, I need to divide by 8 on both sides. So that will get that by itself, and I have 4 square root of 3 over 8. I'm going to just focus on the 4 over 8. That simplifies to 1 over 2. So I have over here 1 times square root of 3 over 2. So we just said the box over here is actually what we replaced with cosine of x. So I'm doing cosine of x equals square root of 3 over 2. So this is going back to what we did before with those general solutions from the past examples. And then I'm going to look back on my unit circle, find out what those general solutions are for that. So I'm just going to include here, since it says it's only over the intervals 0 to 2 pi, I don't need to include those multiples of 2 pi. I'm just going to see where it is in the unit circle. It's at pi over 6 and 11 pi over 6. Okay. And then for here, for tangent square root x plus 2 tangent of x. So we can do the same thing as before. I'm going to just change this to z squared plus 2z equals -1, if I think of it like that. Well, since I have these, I have a square here, I need to make sure to factor that out. So I can factor out a z in here. I have, before that actually, since this is a quadratic, I should make sure this is set equal to 0. So I have z squared plus 2z plus 1, because I had to add 1 on both sides, and then I have 0. This is can be factorable, so I can actually factor it like this, and both of those 1 and 2, they would add up together like that. It looks like it's not factorable actually, so it looks like I would have to use the quadratic formula to find that. But what you will get in the very end for this one would be z equals we'll have to look back there. So this one ends up being just with 1 apparently, or -1. Okay. What you'll end up here is, in the very end, you should just get as a tangent of x equals 1, or -1, excuse me. And then by the end, you should get that you have x is equal to 3 pi over 4 and 7 pi over 4. Right. So these are a few more examples to look through. These are generally the same as what you had before, but this, just keep in mind that they're going over the interval of 0 degrees, 360 degrees. So same idea as what you did before. It's just that you're looking at the degree measure for it. So for this one, 2 square root of theta minus 1 equals 0. I have, I'm just going to, again, aim to get just sine by itself first. So I should add 1 on both sides. I have 2 sine squared theta equals 1. And then I need to divide by 2 on both sides here. Now in here, I have sine sine squared of theta equals 1/2. I will need to take the square root on both sides, and since I'm taking the square root on both sides in an equation, then I need to have a positive and negative for that. So that's going to be sine theta equals 1 over square root of 2. That's the same thing. That's the same thing as doing square root of 2 over 2. So with square root of 2 over 2, that has to do with pi over 4. So then for pi over 4, then you have here, it's going to be a positive. Wherever you had square root of 2 over 2 in your unit circle, it's going to be of those pi over 4s, but are also including the negative square root of 2 over 2. So back on your unit circle, it's going to include at pi over 4, it's going to include at 3 pi over 4, also 5 pi over 4, and also 7 pi over 4. So you're going to have all of those there. Okay, so let me make sure to put that in there. This is in degrees, so I'm going to make sure that's in degree measure here. 45 degrees, 35 degrees, 25 degrees, oops, and 15 degrees. Okay. You're going to see these types of examples in your assignment for the first assignment, and then I will look over some other examples for your second assignment this week.